But before we do example number 2, let me talk about some terms, okay? The first term I want to talk about is a variable. Now, in both of those, we had numbers, and those numbers can be represented by a variable. So a variable is really a letter or symbol that represents, or as we say on the street, reps a number. N, X, smiley face, winky face. Actually, that's more of a pirate face. Okay? But those represent numbers. All right? So before we said that we had shapes. Well, we could say that n represented the number of sides. And to get from shape to shape to shape, what we did is we did n plus 1. Right? So we could say n 1 equals 3. n2 equals n1 plus 1, or 3 plus 1. n3 equals n2 plus 1, which was 4, 5, and so on and so forth. So there's a mathematical thing. I did a real simple example for example number 1 to kind of get your idea around it, but in Algebra 2, we've got to put a formula to it. So the first thing we need to know is that we could have a variable, which is a letter or a symbol that represents a number. And that helps us to make these predictions in these patterns. Does that make sense? Are there any questions about what a variable is? Another term that we could use, or that we could say, is we could talk about what we call a numerical expression. So this right here is a numerical, whoops, I apologize. That's not the numerical expression, this is. And we'll just delete this. And this is the numerical expression. Now, why did Mr. Adams delete what I had up there? Why did I move that? Well, notice that there are no variables there. 3 plus 1 is a numerical expression. 3 plus 1 is a numerical expression. But this is Algebra 2. So we would call this an algebraic expression. So algebra is really about taking letters and letting them represent numbers that we don't know and manipulating them using all the rules of math and getting the variables by themselves and solving most of the time. So that the one in blue is an algebraic expression. The one in red is a numerical. Numerical doesn't have a variable. So all the math you learned up into algebra or pre-algebra had no variables, no letters. That was all numerical stuff. As soon as you put a letter in there, it becomes algebraic. Okay? All right, so now we're ready to do example number 2. Example number 2 still has a pattern, but now we're going to try to use some variables. So they're going to use toothpicks. Okay? This is figure 1. This is figure 2. This is figure 3. Well done, Mr. Adams. They're just adding an extra square. All right. Well, each one of these lines is a toothpick. They're just building something with a toothpick, making a shape with toothpicks. Your textbook wants to know, hey, how many toothpicks would you need for the 20th figure? Well, we'll say figure 20, since I wrote it that way. So how many toothpicks would you need? Well, let's see if there's a pattern, and then we'll try to use some algebra. Well, the first thing I'm going to do is, what variable do we want to use to represent the letter or the number of toothpicks? Yes, t. T. So we'll say t equals toothpicks. And so for here, I have 1, 2, 3, 4. So here, t equals 4. That's figure 1. Here, t equals 1, 2, 3, 4, 5, 6, 7, 8. We don't want to count it twice. Before I even get started, how many do you think we'll have here? And the next one? Yeah, 12. 12, maybe. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So far, so good. So t equals 12. So I could represent this another way. Now we want to do some algebra. So one thing I could do is I could say figure and then the value for t. So figure 1, I had 4. For figure 2, I had 8. For figure 3, I had 12. If you were to guess, what are we doing over here to get from 4 to 8? Yes?
Adding another square for 2.
Well, yeah, but in terms of t, numerically, what are we adding?
4t.
Yeah, so we're adding 4. It makes a square. He said we're adding a square, yes, but it takes 4 toothpicks to make a square, right? So we're adding 4, and we're adding 4. So there's a pattern there, right? A mathematical pattern, we're adding 4, right? What are we doing over here? Mathematically, to get from 1 to 2. Adding 1. Adding 1. Now there's lots of ways we could do this. Do you guys want to add 4 20 times and see what you get? There might be a shortcut. So what's the mathematical, what can I do to 1 to give me 4? What can I do to 2 to give me 8? What can I do to 3 to give me 12? Yes?
Multiply by 4.
Yeah, so I might say that t how do I write that down as an expression? Could we say that's equal to the figure times 4?
Yeah.
Yeah?
Yep.
And we'll think of figure as a number. Well, what figure are we looking for? Well, let's test this theory out. So t is equal to figure 1 times 4 equals 4. Hey, you know what? That worked. Let's try it again and see what we get. T is equal to figure 2 times 4. That equals 8. Hey, guess what? That worked. Let's do it one more time. T is equal to 3 times 4. That equals 12. Hey, that worked. All right. What do I write down here? What expression do I write? Yes?
T equals 20 times 4.
Algebra is pretty nice, right? Now that's the correct answer.